Hey everybody, it's Miss Corso here, and I am trying my first attempt of doing our first lab of the year online, remotely. I have in front of me on my actual screen of my monitor the density lab. This can be found in your Microsoft Teams. It is linked right to today's assignment. It is also in the notebook, but only under teacher content, so you probably won't find it there. But definitely it is linked to your assignment. You'll see, just click on it, say density remote, density lab remote, I believe. So just click on that link and it'll come right on up and you will be able to edit your answers within this lab. So it should be pretty easy to do and submit. But you definitely have to watch this video in order to actually do the lab itself. So I just want to get started here. You should be filling out your name, today's date, the instructor, which is me, the period, for whatever period you have me for, and of course partner, it doesn't exist here on this. And we're going to get started right away. So introduction is that density is a term that is used to describe the relationship between the mass of an object and its volume. Under given conditions of temperature and pressure, the density of a material is constant. The density of any earth material can be determined by using its mass and volume and using this equation, density equals mass divided by volume. Now the first thing you're going to do is you are going to pause this video. When you pause this video and you go to your worksheet, okay, which is obviously what we're looking at right here, that link, your density lab itself, the first thing that you are going to do, let's get my pen moving here, is you are going to define, okay, these terms. You need to define what the mass of an object is, what its weight is, its volume, and this idea of water displacement, which I showed both on the video figuring out density, as well as we went over in class for those of you that were in class today, but water displacement, and I will also be showing you this during the lab today. So these are the first things that you have to define. Again, you can Google these, look them up, get a definition down. Okay, once you unpause, you come back to this video. We're going to start the procedures. You really do not need to read through these procedures. There are some things that we are omitting today. So we are going to go straight to the next page, which is going to be our report sheet. So everybody should be at report sheet 1. I'm going to tell you right off the bat that we are not going to be doing report sheet 2. So you may X that out right now. Again, once we're done with report sheet 1, we're going to skip right over report sheet 2, not doing any of that. And we're going to go straight to our conclusion questions, which are based on the lab procedures that we do today. So we are going to be starting looking at, hopefully you paused and you figured out your definitions and now you're back, but we are going to be starting to look at how to figure out the density of some different items. Okay, so the first item says aluminum bar. Your second item is your aluminum cube. We are actually going to cross out aluminum sphere, and we're going to do, instead of an aluminum sphere, I am going to write that in as a wooden block. So wooden block, if you will. You're going to fill that in. Okay, you're going to do a plastic sphere. Number 5 is going to be a glass sphere. See if I can make this a bit smaller. Hang on one moment. And so I can write in the lines a little bit neater. So this is going to be your glass sphere, G-L-A-S-S sphere, otherwise known as a marble. Okay, your next one is going to be your clay sphere. So we are going to put that in as number 6. This is just a piece of clay. You'll see it in person in a second when I put it up on the screen. Okay, and your last one, number 7, is going to be a piece of granite. Granite is a rock, so you'll see it looks like a rock. It's actually the rock that many people form into their kitchen countertops, and that's spelled G-R-A-N-I-T-E, and you could even put rock afterwards. Again, sorry for the sloppy writing. I got so many things on my desk here trying to make this happen for you. So you guys got number 1 is the aluminum bar, number 2 is the aluminum cube, number 3 your wooden block, it's a block of wood, number 4 we're going to do a plastic sphere, number 5 a glass sphere, number 6 a clay sphere, and last will be a granite rock. Okay, so let's get going here. So you should see, obviously on my screen share here, you see me down in the corner. Hi, there I am, right? I'm going to move this up maybe over here, right over here. And I want you guys to take a look, right? So maybe I make myself a little bit bigger to do this with. Let's see if I can make this more full screen. There you go. So the first thing that we're going to be doing today is we're going to be figuring out the mass of each one of those items that we just filled in on the report sheet. Okay, so we've got a start of an aluminum bar. And if you look at your report sheet, right, if we kind of flip back or we kind of look, I can't do that without minimizing, but the report sheet where it says aluminum bar in the first box, it says mass equals with a blank. To find the mass of each item, okay, what we need to do is we need to place it on a scale. So here I have a scale, right? I'm gonna just basically turn my scale on, okay, and once my scale is turned on, okay, hopefully you can get a kind of a view of the actual screen in there, okay. What we do is we make sure the scale reads 0.0 and we place, okay, onto the scale what we are going to place. Now my scale is not reading 0.0. I got to get it on a flatter surface here for you guys. Let's see if I could tilt my screen down just a bit. Make sure that I'm recording this on my screen. And what I'm going to do, you know what? Just let this up a bit so you can see, is I'm going to get my mass. There we go, that's a bit better. Okay, I'm going to get my mass 0.0, rescale this, re-tear this 0, and I'm going to get my mass of my aluminum bar by just simply placing it on the scale. Now I know this is backwards in your screen, but it does read 37.7. So what you guys are going to do, if I minimize this back down, is you are going to go back to your sheet, and for your first one, we are going to write in the mass of your aluminum bar right into this blank. All right, you guys should see the blank right there. Get my pen back up, small ink, and we are going to write in the mass right into that blank. So let's get over here, 37.7 grams. Okay, now we're going to go and take the masses of all these things. We're going to not just do one at a time for a mass and then, you know, the volume. We're going to get the weights of everything first. Again, that's your mass. So I will go back here. Let's minimize this. Get me back up on the screen. And let's go through all of them. So I won't be going back to the report sheet for all of them. I think that you could probably listen and write it down. So let's go for the second one. So the second one's going to be your aluminum cube. I'm going to take your aluminum bar off, and we're going to put the aluminum cube on. Again, always check your scale to make sure it reads 0.0. And your aluminum cube, I know it's backwards in the screen share, but your aluminum cube actually has a mass of 5.5. So everybody go to your aluminum cube where it says mass equals 5.5. Okay, I'm going to take this off. I'm going to weigh my next item, which is my wooden block, get its mass. Always check to make sure it's 0.0. I put it on, and my block of wood comes up as 51.4 grams. Okay, so you should have that written down. I'm going to go get my mass of my next object, which is my plastic sphere. And my plastic sphere, it may roll off a little bit, but we got some nice little edges here. My plastic sphere is 0.9 grams. Okay, take this off, and I'm going to go to my glass sphere. So my glass sphere, okay, my glass sphere is 3.8. Okay, and my next one, let's see if I can exit that. Okay, and my next one is going to be a glass sphere, clay sphere. So we got my clay sphere is right here, and that has a mass, my clay sphere, of, let me just make sure that's on 0.0. Yeah, so my clay sphere has a mass of 1.5. So everybody should write down 1.5. I'm going to just record that on my report sheet as well. And then my last and final item that I'm going to be finding the density for is a piece of granite. Again, your kitchen countertops are, you know, you'll see them in pizzerias made up of that. And that comes out to 55.0. So right now, all I did is I found the mass of each item. And I read it out to you. We will go back right now and we will actually make sure that we have that recorded on our report sheet. I think it's easier to do that way. So if I minimize this back down, say goodbye to me for a second. Let's bring this right back up again. Okay, and we are supposed to write in each one of those masses. So let me put my scale down and just get some of these items cleared off of my desk. And here we go. So the first one we wrote in is 37.7 grams. The second one was our aluminum cube. So right up here at mass, you're supposed to write in the mass of your aluminum cube, which was 5.5 grams. Okay, your mass of your wooden block, we got to be 51.4 grams. Your plastic sphere was 0.9. That's less than the density of water. Therefore, if it was put in water, that plastic sphere would actually float. We're getting down to our glass sphere, and our glass sphere has a density of 3.8 grams. Notice all things here are in grams because that's what they are measured in on the scale. Let me see if I can just scroll down a little bit and bring this up. And we got our next one, which is our clay sphere. And our clay sphere has a density of 1.5, 1.5. So if you place that in water, obviously it would sink, right? Greater than the density of water, which is 1. And we got a granite rock, which is 55 point, I think it was 0 grams even, right? 55.0. So we got the mass of everything by simply weighing it. And now we're going to go back and get the length, width, and height of some things if they're a regular shape using a ruler. And then we could also find volume with our graduated cylinder or our beaker if they're not regular shape. So let me minimize this back down for a moment. Okay, and we're going to go right back to my screen share and make this big so you can see what's going on. And there I am again. So here we go. We need to get the volumes of each one of these things. So I'm going to pick up my ruler. My ruler is going to be, this one has both inches and centimeters. I'm going to be using the centimeter side of my ruler, okay? And what I'm going to be doing is I'm going to start with my aluminum bar. Now to find volume, there's 2 methods of finding volume. You can either use your ruler, if it's something that's regular shaped, like my bar or my cube, or you need to use the graduated cylinder method where you'd use the water displacement. So here we go, starting with my length, width, and height of my aluminum bar. So the length is the longest side. For my aluminum bar, it's going to be 8.8, so 8.8 centimeters. Okay, my width, I'm going to go with this kind of shorter side here, and my width is going to be 2.5 centimeters. And then my height, I'm going to use this edge of it, is going to be 0.5 centimeters. So again, 8.8, 2.5, and then this little tiny edge is 0.5, 0.5. Okay, so you're supposed to record those all in underneath where it says aluminum bar, length, width, and height. So let's go on to my aluminum cube. Now if you notice, the cube has all the same sides. So all you have to do is really measure one side and that will give you the length, the width, and the height. So here we go. The length, width, and height, all 3 measurements of my cube are 1.2 centimeters. So 1.2, width is 1.2, height is 1.2. Okay, length, width, and height. So next one, okay, is going to be my wooden block. If I take my wooden block and I put it down here on my ruler, I'm going to get my length. Got my little measurements already pre-video, but I'm measuring it for you again. My length, the longest side I have down as 6.5. Okay, the width, okay, I have, actually, let's do this as your width, down as 3.7. And your height is going to be 4.9. Okay. Now, plastic sphere is very different. You cannot do a length, width, and height with something that's a round or spherical or even irregular shape like a rock. Okay, if it's not boxy and kind of have edges or not a regular shape, you have to usually do the water displacement method, which is very simple. For my first one, which is my plastic sphere, all I'm going to do is I'm going to take my graduated cylinder. Okay, I'm starting with 20 milliliters of water in it. I tilt it to the side. I roll my bead in so it doesn't splash water out. And when I rolled my bead inside, I started at 20 and now I am at 21, meaning that that has a volume of 1. So once I'm done with that, I'm going to remove my water out. I'm going to put a little bit of water back in again. You could start over, or you just could have started from 21. Okay. Right now I am starting at, I believe, 21, 22, 23 milliliters. I got 23 milliliters in here, and I'm going to find the volume now of my glass sphere. So I tilt it, and it went from 23, I should really have this flat, to 24. So again, that has a volume of 1 milliliter. And I'm going to start at 24 this time. I'm going to put my clay sphere in, tilt it to the side, roll it in, and it went from 24 to 25. So that also, all three of these things are the same volume. They all have a volume of 1 milliliter. Okay, so that leads me to get one more volume using the water displacement method of my piece of granite. All I need to do is find out my starting, and my starting number for my beaker of water here is 100. I tilt it to the side, I place the rock in there, put it back down flat, and it reads 125, which means that when I place the rock in there, if it went from 100 to 125, we have a water displacement of 25. So 25 ml. So if I go back to my sheet here, my report sheet, okay, I'm gonna minimize me again and maximize my report sheet. I can easily write in all the values, which you hopefully did as we were doing this, but if you didn't, not a big deal. So let's do this. Your aluminum bar length was 8.8 centimeters. Make sure you have your centimeters in there for each one. 2.5 centimeters, right? And your height was 0.5 centimeters. What your job is to multiply all three of these out to get your volume, and then you do mass divided by your full volume to get your density. Now remember, your mass was in grams, your volume is going to be in cubic centimeters. So again, once you multiply 1, 2, 3, multiply them out, get your volume, and then you'll do 37.7 divided by your volume to get your density. Okay? Aluminum cube is done the same way. I believe our aluminum cube had a length, a width, and a height, all of the same, 1.2, 1.2, 1.2 centimeters, all of them centimeters. You're going to take your calculator, you're going to multiply 1.2 times 1.2 times 1.2. Whatever you get when you multiply them out, that's going to be your volume, centimeters cubed, and then you do 5.5 grams divided by whatever you got for your volume, and you'll get your density. Okay, remember your density is going to be grams per cubic centimeter for units. Okay, wooden block. We had a volume, well, we had a length, a width, and height. Again, I'll write it down here. Your length was 6.5 centimeters. Your width was 3.7 centimeters. And your height was 4.9 centimeters. So I'll squeeze that over here, 4.9 centimeters. Again, you multiply 1, 2, 3 out, and that will give you your volume in centimeters cubed. And then you just do mass divided by volume to get your density. Okay, plastic sphere, we had a volume of 1 ml. This is simple. You'll do 0.9 grams divided by 1 ml to get your density. Glass sphere, again, it was 1 ml. And clay sphere, 1 ml. And again, same thing. You're going to do the mass divided by the volume to get your density. With examples 4, oops, sorry about that, examples 4, 5, and 6, I don't know where that just went. Let's see if I can get that back right in the middle of this. Examples 4, 5, and 6, oh, disappeared. Hold on, let me see if I could figure this out before we get any further. Hang on. Sorry, almost interruption there. So examples 4, 5, and 6, I just want to let you guys know because we got cut off right there, something disappeared. 4, 5, and 6, they are all going to have, okay, the same exact units because you got grams and you got milliliters, okay, it'll be, again, mass divided by volume, mass divided by volume, mass divided by volume, but again, grams / ml, okay? Now, your final one was your granite rock. You put it on the scale, we got 55.0 grams. Your volume for that one, we recorded it before, at least I said it before, we didn't write it down. Your volume is going to be 25, right? And it's going to be 25 ml. And all you have to do is pick up your calculator for this one, do 55 divided by 25, and that will give you your final answer for density. And again, grams per milliliter will be your units. Okay, so hopefully that was pretty straightforward for you. All you have to do once you're done doing your division is skip right over report sheet 2. I have that crossed out, and then you are going to answer all questions. Okay, it is absolutely imperative that you do all 1 through 5 and the conclusion. If you leave anything incomplete or blank, it is not acceptable for a lab. So you do want to make sure that you answer all these questions. And I will tell you, just to make your life easy, okay, number 1, 2, 3, 4 are all in your video online. So if you go back to the density videos, specifically the density video number 2, part 2, right? Part 2 that was uploaded on Tuesday. This video right here online will actually give you answers for 1 through 4. Number 5, you're going to have to think about. And of course, number 6 is what we did in this lab. How did I figure out the density of a common earth material? We weighed it first to get its mass. We calculated the volume out either using our graduated cylinder or, of course, length times width times height. And then from there, we divide. Okay? I really, truly hope this helps. And if it doesn't, I would rewatch it again because it really, truly does give you lots and lots of answers. And I think that should be about it for today, folks. So good luck with your first lab. And of course, I'm on the other end of this if you ever need me. All right, I will talk to you later. Be well. Bye-bye.